Hello and welcome class 7 students. Today also I will continue with the formula chapter of algebra section. So exercise 12 we are doing and we have learned the applicability of these two formula, that is a plus b whole square and a minus b whole square. Now we have learned that how a plus b whole square and a minus b whole square can be given in different forms, and we have to write the answer in this form, that is a square plus 2ab plus b square or a square minus 2ab plus b square. Now the reverse thing may be given to you. The reverse thing may be given to you, that means suppose this part will be given to you, and with back calculation you have to find out a plus b whole square, that is the first and the second term, the actual two terms whose square we are being given. I will help you to know this with the help of an example. Suppose you are given a square plus 2ab plus b square. This thing you are given and you are asked to find out whose formula is this. You have to express this as a perfect square. Express this as a perfect square of two terms. In that case, what will we do? We generally write this one, that is a, and the second term, that is b, and from here we write plus sign. So we can easily conclude that this is the formula of a plus b whole square, because here the first term is a and the second term is b. So writing the first term and the second term, and from here we can conclude that the sign symbol will be addition. So this is the square of a plus b whole square. In this way, the derivation will be given to you and you have to find out the actual perfect square, actual square of the two terms. You have to find the two terms. Express this as the square of the two terms. In this way, that is, the derivation will be given to you. With back calculation, you have to find out the first term and the second term square. How you will do? With the help of an example, I am showing it to you. Suppose you are given a sum 25x square plus 40xy plus 40xy plus 16y square. This sum you are given and you are asked to express this as a perfect square. How will you do this? See, 25. We can see 25 is the square of 5x. 25x square is the square of 5x plus. Generally we write 2 into first term into second term. So 5x is the first term, we will write this first. Into the second term. Now we don't know what is the second term, but here from 16y square we can find out what the second term is. 16y square is the square of 4y whole square. So from here we can learn that the second term is 4y. So we will write 4y. Now you can see 2 into 5 into 4 is coming 40. So with back calculation we are trying to match this second term. This one, 2 into 5 into 4 is 40. So 40xy is equal to 40xy. We are doing the sum rightly. So from here we can easily understand that the first term is 5x and the second term is 4y. So simply we will write 5x plus 4y whole square. So this result is the whole square of 5x and 4y. So you can understand how with back calculation we are coming from this to the initial line. We are coming to the initial line, that is, this derivation is given. From there we are finding out the square of the two terms. Here also derivation is given. From this we are finding out, originally it is the square of 5x plus 4y. If you can do the whole square of 5x plus 4y, you will definitely find out 25x square plus 40xy plus 16y square. With another example, I am going to show you how it works. Suppose it is given to you that express as a perfect square, 36m square plus, no not plus, minus 12mn plus n square This is given to you. With back calculation you are asked to find out that whose square is this, whose result is this. That means you have to find out the terms whose square is coming as this. This is the result. You have to find out the original term, the square of the two terms, the square of subtraction or addition of the two terms. So 36m square is the square of 6m. So we will write 6m whole square. From minus we will write minus. Then second, 2 into a into b. Now since it is minus, we will definitely get something like this, a minus b whole square. That is the subtraction, the square of subtraction of two terms we will get. So we will write the minus over here, minus 2 into first term into second term. Here the first term is 6m and second term we don't know. So let's write the second term first. Here n square is the square of the second term. So n is the second term. So 6m into n, 2 into first term into second term, 2 into 6m into n, and that gives you 12mn. So we are doing it rightly. So ultimately this is the whole square of 6m the first term minus n the second term. So 6m minus n whole square is this. In this way you have to solve the sum. Again let's do another sum where through back calculation we have to express as a perfect square of two terms. Suppose it is given 81x square, 18xy, 81x square, 18xy and 81x square plus 18xy plus y square. So through back calculation you will find out whose square this is. So 81x square, so it is the square of 9x whole square, plus is there, so we will definitely write, that means we can relate with the formula of a plus b whole square. So plus we will write because of having plus over here. Here we will write 2 into the first term, that is 9x, and the second term, that is y, plus y square. Second term is y, so y square. Here we have written 2 into 9x into y, that is 18xy, which is matching with the first line. Matching with the first line is very important. That means you can guess that your sum is being done rightly. So it is the whole square of 9x plus y. It is the whole square of 9x plus y. In this way, through back calculation, you can find out whose square it is. You can express this as a perfect square and find out the original line through back calculation. So we have learned two things back to back. How to apply the formula if something is given and you have to find out the square, or if the square term is given, the derivation is given, through back calculation how to find out the original perfect square, subtraction or addition. In this way we will solve this kind of sum. In the next classes I am going to come up with more types of sums in exercise 12. Wait till that.